So in this second section, 7.2, we're going to be estimating a population mean. And I definitely think it's necessary to see the previous lecture or video of estimating a population proportion before diving into this section, because a lot of the things are very similar as far as, how you write the forms of the estimation, like the confidence intervals. There are different ways to write them. So you'll be doing a lot of the same stuff in this section. It's just different calculator functions that you'll be using to process the population mean or estimate the population mean. So, and yes, just like p hat was the best point estimate for the population proportion. X bar, which of course we all know that as the sample mean, that is going to be your best point estimate for the population mean. Okay, since X bar is an unbiased estimator of mu, the population mean. So there are actually two calculator functions that you have to use on the homework at various times, and one of them is Z-interval and the other one is T-interval. They are both found under that same menu when you hit stat, when you hit the stat button, and then you go over where it says test. The top menu says test. Both of these calculator functions are under this menu. Now, at the very top we see Z-interval and T-interval, or sorry, Z-test and T-test. You don't want to pick those though. You want to actually go down a little bit further. It's on number 7 and number 8 on my calculator as far as options, but Z-interval and T-interval are down there, and those are the calculator functions you'll be using. Now, how do you know when to use which one? And that's probably like one of the biggest obstacles. For the most part, you will be using T-interval in most like real life situations and most of the problems on the homework. But if you see sigma, so the population standard deviation, that's the symbol for population standard deviation. That's when you're going to use Z-interval if they give you that, okay, if they give you that value. Now, most of the time, if the problem does not give you sigma, okay, which is the population, remember that as the population standard deviation, that means you're just going to use T-interval. So that's basically how you know when to use which one. And of course, there are 3 different ways you can write your confidence interval for the mean. You can have it with this notation with the less than symbols. We are estimating the population mean, so I'm going to put that mu symbol right between those two less than symbols. Okay. You can also have it in this margin of error form. So margin of error, we'll be back. Just make sure you know how you best calculate margin of error. There are many different ways to do that. And then this way with the parentheses, that's usually the way the calculator gives you, that third way down there. So, and then there's the formula for E again, in case you need a refresher from the last time. But that's an easy way to calculate the E right there. Of course, there are other ways as well, like we discussed in class. So, looking down at this problem, let's work it together. It says randomly selected statistics students participated in an experiment to test their ability to determine when a minute had passed. And we have 40 students yielding a sample mean of 58.3. It says assume that sigma is 9.5, so this is where like the real life stuff kind of goes out the window. Usually you will never know the population standard deviation at all, but they're saying like assume it's 9.5 right there. Okay, this first problem says what's the best point estimate, which is a quick estimate for the average time or mean time for students to guess a minute. So basically, your best point estimate when you're trying to figure out mu, your best point estimate for that is going to be X bar, the sample mean. So X bar will be your best point estimate. And that, in the problem, they tell us the 40 students yielded a sample mean of 58.3 seconds. So on average, it took them about 58, it's a little bit more than 58 seconds to guess a minute had passed. Okay. Now, on the next part here, it says now construct a 95% confidence interval estimate of the population mean of all statistics students. Okay. Now, this one is wanting us to estimate the population mean. So there are two calculator functions that we could possibly use. We could use z-interval, or we could use t-interval for estimating a mean to get a confidence interval for a mean. Well, in this problem, we're actually going to use z. And if you hit z on the calculator, z-interval on the calculator, you'll see, first off, you see this input data and stats right here. Data, you mostly would just use data if you had like a list of data. There may be one problem in the homework that has that, but yeah, most of the time, like, you're just going to be given the statistics, the summary stats. But if you had like a full list of data, like all your data points, and they didn't give you like the mean and the wording or whatever, then you might use data. But for us, we're going to use stats, and then you just got to fill in these fields here. But you'll see on z-interval, see how it has that little sigma symbol first? That's basically how you know to use z-interval instead of t-interval. But that's where we're going to be putting in our 9.5 in that part right there. So we're just going to write some things down here just so we have it for ourselves later. We're going to do z-interval. We're going to put since sigma given. Okay. And then you just got to put in your values for that. So we're going to put in sigma of 9.5. We're going to put in x bar. They gave us a sample mean was 58.3 seconds. And then what else do they give us? X or n. N, it says 40 students. There's 40 students in the trial. So we're going to put 40 as our n. And then C level, they usually give us that. It says construct a 95% confidence interval. So we're going to put 0.95. You could also put 95. It actually converts it okay. But I just changed it to a decimal. Just to reinforce that that's how percents are wrote as decimals. Okay, and then once you hit enter on all of that, it'll actually give you the confidence interval in the first form. Now we'll actually practice writing this in the different forms, so maybe give you a little practice there on that. But it looks like it gives us 55 point. We'll just do one decimal place, so 55.4 seconds to 61.2 seconds. So that would be like one way you could write it right there. You could also write it with the inequality. So 55.4 seconds less than mu, because that's what we're trying to estimate, less than 61.2 seconds. That's another alternative way. Sometimes MyLess will have you, or your homework system, will have you write it with the less than symbols. And then last but not least is the plus or minus e form. Now we just need to find the sample mean, which we already have that. And then the e, which is the margin of error. And you can get that a lot of different ways. You can do the subtraction problem where you say, and you might want to do this on the side somewhere, but you're basically going to say 61.2 minus 55.4 and then divide that by 2. That definitely works. Okay. You could also see what the distance is from the sample mean to an outer edge, like from the sample mean, which is 58.3. How far away is that from 61.2 or something? That would also be e. But this is the way a lot of students do it. Is the 61.2 minus 55.4 and then divide by 2, and we get 2.9 as that value. So that would be your sample mean. So 58.3, basically, let me write this in with units. Seconds plus or minus 2.1 seconds. So that would be what your confidence interval looks like with the plus or minus form. And then this part right here, you're just going to use that template that we had in the first section to interpret your interval. The only thing, you just have to make sure you change it from population proportion to population mean now. So this is basically what you'll have going on here. We are, and this one's 95% confident. That the interval from, and then you'll just put your upper and your lower range. We got 55.4 seconds to 61.2 seconds actually contains we'll say true population mean, and then you want to put like a descriptor for what your mean is. It's the population mean of students to guess a minute. Stat students to guess a minute, I think is what it said. But I'm just going to put student to guess a minute has passed. Okay. And that's basically what you have going on there. That's to be your interpretation that you look for. And then this next part says, based on the results, is it likely that the true mean, mu, is reasonably close to 60 seconds? You know, your range actually includes 60 seconds in it. Like 60 is between 55.4 and 61.2. So I would just say yes, since 60 is in that middle of those two. You would say probably yes, it is reasonably close. I mean, your interval is kind of straddling the 60 seconds, so you are really, really close to about 60 seconds there. Okay, let's look at another problem here. So in a test of Atkins weight loss program, we have 40 individuals, so I know that will be my N right there, in a randomized trial of overweight adults. After 12 months, so they did like a year study, the mean weight loss was found to be 2.1 pounds. So that would be your X bar right there. And then with a standard deviation of 4.8. So this standard deviation right here, it may be hard to read it, but see how we don't see the sigma symbol? This is actually sample standard deviation right here. So this is the standard deviation of the actual sample. And this is more like what you would have in real life, something like this right here. So that would be your S or your SX on the calculator screen. I think it has a little X beside it. That would be what your standard deviation is for your sample, not your population. Okay. Now, part A is just what's the best quick estimate for the average weight loss of student or people in that program. You're just going to say for your point estimate. Okay, you're going to use X bar as your point estimate, which is 2.1 pounds. That'll be your best quick estimate. Like you're just trying to get a quick number for the average weight loss on a year, which is not a lot actually. Which probably, you know, there could be a lot of things that made people not lose a lot on the program. I mean, maybe people didn't stick with it the whole year or something like that. But anyway, which it's a low carb diet anyway, so very hard to do those. Very, very, very difficult. But anyway, this next one, part B, says construct a 95% confidence interval estimate for the population mean weight loss of people on Atkins. And it says it wants us to write it in 3 equivalent forms. We won't do that part again, but we will get the interval for sure. So on this one, what are we going to use for our estimating the population mean? Well, you want to estimate population mean, you're going to use either Z interval or T interval, one of those two calculator functions. And you're like, oh, which one do I pick? Well, when you don't have the sigma symbol, you're going to actually use T interval, the T. Okay, so we'll use T interval this time. And it's because no sigma symbol. Okay, and of course, make sure you pick stats on this. Like I said, unless you had all 40 people's data, like all 40 people's weights, which might be interesting to see. You know, like the ones that lost the most probably are the ones that stuck with it. But I mean, anyway, but if you had all their actual weight loss, you know, like in a spreadsheet or something, then you'd use data. But since we only have the summary stats, we're going to use stats. And see how in here we have the S with the X. It's the second one down. That's how you know you're also going to use T interval. What's another way to check it? So we have the SX, which will be the 4.8. So I'm going to put all this info in. And we do have 40 people still. And it's a 95% confidence level. Yep. And let me just write this down. Always make sure you're documenting for, in case you never ever need to reference your notes when you're doing your final, or you know, you're getting ready for your test. Or even your homework, obviously. That's when you really want to use your notes. But I'm just going to put down all my stuff that I've entered in my calculator. And now I want to calculate, and it'll give me the average weight loss, a range for the average weight loss of people on this program. Okay, we're just going to say like 0.6 pounds, and then 3.6 pounds. So anywhere between 0.6 and 0.3 pounds. That's going to be your confidence interval. And then, of course, you could write it in different ways, different variations, just like we did in that last problem. That part will be the same if you choose whatever way they want you to enter it in MyLabs Plus. You'll just pick the way that works. And then interpret the confidence interval constructed just above. That's going to be very similar to the wording of the previous problem. The only things that will change, the only things that really would change is you'll say like the true population mean, and then on the last part of that, you're trying to say the interval actually contains true population mean of people doing Atkins for a year. So the only part that really changes for interpretation will be that last part. So I won't do that either, but it'll be very similar to how we interpreted the one with the students guessing a minute. So it's going to be very, very similar to that as far as wording goes up until the very end. And then you have this problem right here. Does Atkins appear to be effective? Yeah. And they say, do subjects seem to lose weight at all? Okay. And then, I mean, as far as that goes, does appear to be effective. I mean, people are... Okay, so if you look here at our interval, you can definitely see it's all above 0. So like the entire interval, 0.6 to 3.6, all of that is above 0 pounds. Because 0 pounds would be like you lost nothing, right? Like you lost no weight. So, does it appear people are losing weight? Yeah. It's just not a lot. Does the program seem practical? Yeah, okay. So that's the part that I'm thinking about right here is the practicality of it, right? Is it a practical diet program? I mean, probably not, based on this data anyway. I'm not saying it doesn't work for everybody, but anyway, is it practical? We're going to say not practical, but it is effective, or it does seem like it is effective, based on their definition of effective here, at least what they're saying is effective. Not practical, but there is a little bit of weight loss. So, sort of effective. Anyway, that's basically what you want to say, something like that. And on MyLabs Plus, usually you'll be generally picking like different options. You pick the one that makes the most sense with the problem on that. Okay. And then the last example here, this one actually is a little different. And let me show you how this one's going to be handled. It says the ages of randomly selected race car drivers are given below, so they give us a lot. And then it says construct a 95% confidence interval estimate of the mean age of all race car drivers right here. Now, this one, obviously, we don't see the sigma symbol. So when we do our test, we'll have to use t-interval again. But this one, they actually don't give us the summary stats. We're actually going to have to put this data into a list. So when you pick data, like if you pick data under t-interval or z-interval, you'll see it gives you list, frequency, c-level. Okay? Well, the only thing we really need to modify is our list 1, and we want to put in all that data into list 1. So this is kind of a different problem. You won't have a lot of problems like this on homework, but there probably is at least one where you have to put in the data into a spreadsheet. You can use StatCrunch, the calculator, whatever you end up using. We want to do edit, and then we want to put in our data. 32. Let me just go ahead and put this stuff in here. Should have already had it in for y'all. Takes me forever to do this on the computer here, so give me a second. Lost my place for a second. Okay, once you get all that in, just hit stat, go to test, and then you'll be doing Z or T interval on yours, and then you want to pick data, and then just go down to calculate. Okay, on this right here, it looks like we get a range of 29.4. This is ages, so we'll say years old, to 37.8 years. And that would be your confidence interval for those race car drivers. So that's something that's what you want to use right there, something like that. And that is basically how you do the introduction, at least, to confidence intervals with the mean. Then we'll go over this next part in a different video.